Okay, we are looking at 2.4 part 1. We're going to be spending our whole time on something called the chain rule, which is a really major part of the process here for derivatives. So here's what this will look like. The chain rule occurs whenever you have a function inside of another function. So if I go to do the derivative of f, I'm not only going to do the derivative of f, this outer function, but I also have to consider the derivative of this interior function as well. So here's kind of the formula. Here's a pretty friendly look of it. So if I have f of g of x, so we have a composite function, right? An inner function and an outer function. So it starts with just taking the derivative of this outer function, and we leave the interior alone. But then, and this comes the extra part that we got to remember to do, is we then have to multiply by the derivative of the interior function. So let me start taking you through what some of that will look like. So for this one, we have the overall big picture, which is something to the 7th power, but then we also have this interior or inside derivative that we're also going to have to consider. Okay, and so we're just going to start with the outside function, which would be this guy right here. So for the outside function, right, we're just going to view this as something to the 7th power, right? So for the outside function, we have something to the 7th power, and we just have to consider how would we normally do a derivative. We'd multiply the 7 to the front, we'd leave the interior alone, and we would drop that to a 6, right? And so that's going to be the outer derivative, but then the inside derivative is when we look at what's in those parentheses. And so now we're looking at the x to the 3rd minus 5. And we're going to need the derivative of that inside function, which would be 3x squared. And so now let's kind of put all that together according to this layout. So we're going to start with the derivative of the outer function, which was this idea right here where we leave the inside alone. So we got the 7 in front. The inside of this is still x to the 3rd minus 5. And our exponent dropped to a 6. So that's him. But now here comes the extra part where we're multiplying by the derivative of this inside function. And so the derivative of the inside function we said was 3x squared. So we're multiplying this by 3x squared. And then we want to simplify whatever we can. Let's bring these two terms together. So 21x squared. And then x cubed minus 5 to the 6th. Okay, so that's what it all looks like when you put it all together. And really the only new part of that is him, right? We've already done this idea of the power rule. It's just now considering if you have an inside function, we're going to have to multiply by his derivative as well, right? It's got to be part of it. So we have sort of the general power rule, right, which was kind of the initial step that we took on this, right, where we're like multiplying the n to the front and then subtracting 1 from that exponent, right? But we also have this idea where u is now a differential function of x, right? And if our exponent is rational, then, and so here's kind of the rule for this that you want to write down. So remember, we multiplied the n to the front. That was the first thing that we do. We leave the interior alone, so u of x, our interior function. And we subtracted 1 from our exponent. And then we multiplied by the derivative of the interior function. So then we got du dx to represent that interior function. So that's sort of the formal way of writing it. Maybe a bit of a more friendly way of looking at it if we kind of leave out the d stuff, is we have the exponent being multiplied times to the front. We're looking at the interior function we're going to leave alone. We did subtract 1 from our exponent, and then we're going to multiply by the derivative of that interior function. And so we could write it this way. That's maybe a little easier way of looking at it. So let's try that on a couple of these guys. All right, so one thing to consider, as always, is putting this in a bit of a friendlier format before we even try to do a derivative. So we never want the radical. We're going to write that as 4x plus 2 to the 2/3 power. So we just want to get in the proper form first, and then we're going to go through with our process here. So just like we were doing right here with our rule, start with the outer function, multiply the exponent to the front. We leave the interior alone. And we subtract 1 from the exponent. 2/3 minus 1 would be -1/3. And then, this is the part we can't forget, multiply by the derivative of this interior function. And so the derivative of the inside would just be 4. And so we definitely cannot forget about that guy. Let's do a little cleanup. Let's not leave negative exponents in our answer as well. So I got the 2 times 4 on top. On bottom, I got the 3, as well as the cube root of 4x plus 2. And so that would be the best way to leave that one. And let's go down to number 3. Number 3 is going to be a little bit heavier because now we're going to start combining rules. And some of these will get a bit lengthy, but you just got to kind of stick with it, keep with the algebra. And here we go. So this one is now overall big picture. We're looking at a product rule, right? We have a first function times a second function. So we're going to go through our product rule setup, but one thing we're going to consider along the way is there are inside derivatives that we're going to have to take into account. So if you remember our product rule, that's where we do the first times derivative of the second plus the second times derivative of the first. So I'm going to start by doing just the first. So 6x plus 5 to the third. Times the derivative of the second, and here comes our new chain rule. So when I go to do the derivative of this term, again, we're going to start by multiplying that 4 to the front. Leave the interior alone. Drop the exponent down to a 3. So we multiply that to the front, left the interior alone, but now we have to multiply by the derivative of that interior function, which is 2. So first times derivative of the second plus the second, so 2x minus 1 to the fourth. Times the derivative of the first. So again, I'm going to multiply that 3 to the front. Leave the inside alone. Drop the exponent by 1. And now the chain rule is where I have to now multiply by the derivative of the inside function, which would just be 6. So that is it. That is the derivative. The next 2 lines are really just cleanup and simplifying. But here's one thing we definitely need to discuss. If we're going to simplify and factor, so factoring, really we're meaning taking out the greatest common factor. So let's just start with the coefficients here. As far as coefficients, what do these guys have in common? Both of these would be divisible by 2. This is technically 8. This is going to be 18. So let's factor out a 2. And then we're also looking at these type of common terms. They both have this factor and this factor. So remember that when it comes to these factors, we're simply going to take out the one with the smaller exponent. So 6x plus 5 squared. And as far as this one goes, again, I want to take out the one with the smaller exponent, so 2x minus 1 cubed. And now in brackets, I'm going to write what is left over. So if I divided this out of my first term, what would be left? So I still got the 4. The 2 was divided out. So 4 is still there. As far as this guy goes, we took out 2 of these. There used to be 3 of them, so I got 1 of those left over. So I got 6x plus 5 to the first left over. And as far as this factor goes, we took out all of them, so there were none of that one left over. So now let's jump to the other side. So start with the numbers. This was 18. We divided out a 2, which means I have 9 remaining. As far as this factor goes, we took out the entire thing, so there's none of that left over. But as far as this one is concerned, there were 4 of them. We took out 3 of them, so I got 1 remaining. So I got a 2x minus 1 to the first remaining. And so that's what it looks like in factored form. And then if I were to distribute the 4 and distribute the 9 and combine like terms, this is what we got as kind of our final answer here. So let me just start with the first part that we already know. But after you clean up what you see in brackets, we're going to end up with a 42x plus 11. All right, and that's what our finished product would look like. So let's go to the second page. So page 2. Okay, so for this guy, now we're looking at the original function of cosine 5x to the third. And we're going to take his derivative. So again, I'm going to come back to that chain rule. You're going to notice the difference between him, and him with the way that these are written. So this is a really important part of understanding the difference of where that exponent goes and how it changes or affects your process. So with the way that it's written right now, with 5x to the third, that 3 is only hanging on the x. So that makes this parenthesis my inside function, and the cosine of that parenthesis is my outside function. So we're going to do that chain rule where we start with the derivative of the outside function. Derivative of cosine is negative sign. We leave the inside alone, so 5x to the third. So it looks like that. And now we multiply by the derivative of the inside function, which would just be 15x squared. And then the best way to write that, if we clean it up a little bit, would be to put this guy in front with that negative. So negative 15x squared times the sine of 5x to the third. And that's what we got. Okay, so look at the difference in the way this one is now written. This is now doing this entire piece right here to a third power. Right? So now you have a function inside of this function, which is inside of this function. So now on this one, we would actually have to do the chain rule twice, because we have this being the overall outside function, but then I have something to the third power as the middle function, and then 5x is the inside function, right? And so let's just start with the big picture of derivative of the outside function. That's always where this stuff would begin. So the derivative of cosine of 5x to the third would then just be negative sine 5x to the third. So that's just where that starts. And then we multiply by the derivative of the interior function. This whole thing is inside of the sine function. So we're going to take that process where, because this is outside of the parentheses, I'm going to multiply that 3 to the front. I leave the interior of 5x alone. And I take one away from that power, so it becomes squared. But now I have something that's even inside of that. So one more time with the chain rule is now times the derivative of this interior function, which would just be 5. So there's the use of the chain rule twice. Let's just do a little cleanup on that. Let's see. This could now be seen as 5 to the third power. No, we'll just leave it as it is for that guy. But this one we could clean up, because that one's inside of the sine function, so we're going to leave that one alone. But I could say 5 squared is 25 times 3 times 5 times the negative, so negative 375. And then I got my x squared. And then I got my sine of 5x cubed. And so that's the best way to clean up that one. But again, we always have to consider what is inside of other functions, right? And so when they put in those parentheses and the 3 is outside of it, this now creates another interior function. So compare it with one more type. If I were to look at this one, remember when they put the 3 here, that is the same thing as, let me write it over here, when we say cosine cubed of 5x, that is like saying cosine of 5x cubed. So now that 3 belongs to the entire problem. So now the outer function is something to the third power, and then inside of that is a cosine function, and inside of that is a 5x. So I'm still using my chain rule twice on this because I have really 3 different functions for the way that this is written, but the order in which I do it will change because this is now my outside function. And so if I start with the derivative of the outside, I'm just taking that 3, multiplying it to the front, and then subtracting 1 from that exponent. So let's write that as, let me go down here. So I'm multiplying the 3 to the front. I'm going to leave the interior of the cosine 5x alone. And I'm going to subtract 1 from that exponent, so now it becomes a quantity squared. But now, using the chain rule, we're going to multiply by the derivative of the interior function. So again, the derivative of cosine is negative sine. I leave the interior alone. And then now I have to consider the derivative of this interior function, which would just be 5. So now that's what this one will look like. If you do a little cleanup on this, we could simplify it to negative 15 cosine squared of 5x sine 5x. And so that would be the best way to write him. Remember that cosine of 5x squared is the same thing as the cosine squared of 5x. This is really the more appropriate way of writing this. This is the common notation. It just helps to put it on the outside when you're doing the process, just so you kind of organize what goes where. All right, let me jump down to example 7. All right, so again with this one, this is where we do have to consider some options here. So you could do a quotient rule, but typically speaking, the quotient rule is the toughest process. And so if we can avoid that one, we will. So instead of doing a quotient rule, let's write this as x times, I'm going to bring this up top, my 1/3 power is going to become a negative 1/3 power so that I can move this whole term up top. So let's say x squared plus 9 to the negative 1/3 power, right? And now this way we could use a product rule instead of the quotient rule, which is just a bit of a friendlier process. So again, our product rule is the first times the derivative of the second. Now when I do the derivative of this second term, again, this is where the chain rule kicks in. I'm going to start by multiplying my negative 1/3 to the front. We'll leave the inside alone. Subtract 1 from your exponent. And then now the chain rule, I have to multiply by the derivative of this interior function, which would be 2x. So first times derivative of the second plus the second times derivative of the first. So the second, which is x squared plus 9 to the negative 1/3, times the derivative of the first. Well, the derivative of x is just 1, so we're going to write it to show that we considered it, but it's really not going to affect our answer. On this one now, if I wanted to factor out a common factor, so you see that both of those have a common factor of x squared plus 9. Remember, we always want to take out the one with the smaller exponent. So we're going to take out x squared plus 9 to the negative 4/3. And now here's what's going to be left over after taking that out. So remaining, I should have, I'm going to combine those together. So that's going to become negative 2/3. See if I can squeeze it all in there. We got our x squared. So that's what's remaining from the first term. And then now let's look at what's remaining from the second term. Remember, when you factor something out, what you're really doing is dividing, right? So you're dividing something out. Well, what do we do with exponents when you divide? We subtract them, right? So really, when I divided this out, as far as the exponent is concerned, let me just write the x squared plus 9. As far as the exponent on this, if I did negative 1/3 minus negative 4/3, I just get 1. So you don't have to write the 1, but I'm going to write the 1 just to show we identified it. So let's do a little to the negative 4/3. And then just inside these parentheses, I'm basically just combining the x squared and the negative 2/3 x squared would just be 1/3 x squared plus 9. So how would this look if we wanted to write it without a negative exponent involved? Plus we also have a fraction here, so I don't really just want to put this on top and this one on bottom, because then I'd have a complex fraction. We don't want to have that either. So here's how we can do it as one big fraction. So the first thing would be, because this doesn't have a 1/3 in it, to factor out that 1/3 so that I can put the 3 on bottom of the whole thing. So if I were to factor out a third from this factor, that 9 would now become 27. So that's what we got left on top. And then based on what we're seeing over here, we're looking at a cube root of x squared plus 9 all to the 4th power. And so that would be the best way to write it. Let's move on. So for these next 3, what you guys are seeing are really just some practice problems. So I'm going to throw the answers in here. So if you do want to try those and see if you can get the right answer, I'd encourage you to do that. This one is a little bit easier. This one was pretty challenging. And then this one will be really similar to the one that we just did. So let me just throw in the answers. So if you do want to try those and give them a shot, here's the answers that you should come up with. So for the first one, you should end up with a negative 12x times 1 minus x squared squared. And for the second one, this guy had a bit of a lengthier answer. I'm going to try to write small. I'm trying to squeeze in my last factor of 2x plus 7. So there's the way that one would look. Again, consider this whole thing, the way it would begin is the tangent of this all to the 4th power. So similar to the one that we did up above, you would start by multiplying the 4 to the front, leave the interior alone, subtract 1 from that exponent, and then proceed by doing the chain rule on what's the inside of all of that. And then for this guy, similar to the one that we just did, you're going to end up with 3x squared plus 30 on top, all over quantity x squared plus 5, and then a 4th root of x squared plus 5. So especially for those of you looking to move on next year to calc, I strongly encourage you to go through those, give them a shot, make sure this process is working for you. Let me jump down to our final 2 examples. So if you look at cosecant x to the 3rd, we're going to take that same process. Again, with the cosecant of something, like whatever's here, if it's anything other than just x, it's going to have an inside derivative. And so we're going to have to use the chain rule on it. So remember that the derivative of cosecant is simply negative cosecant cotangent. So negative cosecant x to the 3rd, cotangent x to the 3rd. But now I'm going to multiply by the derivative of this interior function, which would be 3x squared. And so that's the extra step to that process anytime this is something other than just x. To simplify it a little bit, I would move this to the front, combine it with the negative, and you got the negative 3x squared in the front, And then you got your cosecant, cotangent. So that's where I would finish. And let me give you one final problem, because we haven't done one of these yet with an e function. So we do have a product rule on this, right? So here's my first and here's my second. Within each one of those terms, you do have an interior function. So this is the interior function of the e, and 2x is the interior function of sine. So keep those in mind as we go through. I wrote this out neatly just so I could fit it in there, so let me show you, and I'll talk you through every step that we did here. So here's what this one's going to look like. So I'm just starting out. Remember, product rule does first times derivative of the second. So first term times the derivative of the second term. So again, we know the derivative of sine is cosine. And then we're multiplying by the derivative of the interior function, which would be 2, plus second term times derivative of the first. And so derivative of e to the negative 3x is simply e to the negative 3x times the derivative of the interior function. So that's what it looks like. And then from there, I'm just doing some cleanup. So down below, right, like on the first one, I just brought the 2 to the front. Over here, I brought the negative 3 to the front. And then on the final step, all I did was factor out e to the negative 3x as a common factor. And if you do that, this is what would be left over. And that's where that one ends.